Hello, in this video we're going to go through 5C of the algebra chapter and looking at equivalent expressions. So just two main ideas or key ideas for 5C. So first of all, two expressions are called equivalent when they are always equal, regardless of what numbers are substituted for the pronumerals. So for example, x plus 12 is the same as or equivalent to 12 plus x, because the order in which numbers are added is not important. Another example is 3k is the equivalent to k plus k plus k, because multiplying by a whole number is the same as adding repeatedly. Okay, so that's two examples of equivalent expressions. And the example we're going to do is matching equivalent expressions. But before we do, let's look at the second point. The rules of algebra are used to prove that two expressions are equivalent, but a table of values can be helpful to test whether expressions are likely to be equivalent. Okay, so a table of values is just a good visual way of seeing whether two expressions are equivalent. Okay, we're just going to do, two questions. I didn't realize I had two questions here. But first of all, let's just do this first question. Okay, but before I do, hopefully I can just make some space for it. Okay, so match up the equivalent expressions below. So let's look at A first. So we've got 3x plus 2x. Now we can add them together. So when we add expressions, they have to have the same pronumeral part. So when you think about it, whatever x represents is going to be the same here as what it is here. So you could say we've got 3 lots of x here and 2 lots of x here. So how many lots of x do we have in total? We have 5 lots of x. So this is matched with C. Okay, let's look at B now. So we've got 4 minus 3x plus 2. Okay, so what we've got here is 3 different terms. Okay, the next section we're going to look at like terms, but this basically means we can, like terms means we look for constants. Okay, so 4 and 2 are what we call constants. So that's going to be 6, 4 plus 2. And then what are we left with? We're left with minus 3x. So let's just see if that's there or whether we have to change that 3x. So if I look here, I can see 6 minus x is up the top there at A. So I can match that there. Okay, just so we've got a bit of space, I'm going to do C over here. We've got 2x plus 5 plus x. Now, as I said before, we can group our like terms. So here we've got 2 lots of x and another lot of x. So together we've got 3 lots of x plus 5. We can't add them together because this has an x on it and this doesn't. So they're not like terms, which is what we're going to be covering in the next section. So let's look for 3x plus 5. There it is at E. Let's go down. Okay, let's do question D. We've got x plus x minus 5 plus x. So how many x's do we have in total? 1, 2, 3. So it's going to be 3x minus 5. So there it is at F. Okay, 7x. Just trying to see. Okay, so 7x is a little bit different because it's kind of working backwards. So we don't need to simplify it. It's already been simplified to get 7x. But we've got two options here. We've got B and we've got D. So if we look at B, we can say, all right, how many x's do I have? They're all like terms because they all contain x. So 2x plus 4x is 6x plus x. So that gives us 7x. There we go. And then obviously this last one is going to be 4 minus x. And when you think about it, we've got negative 3x plus 2x. So 4 minus x. And there it is. All right, let's look at the next question. So I put this one on here because it's a good way of showing you how we have equivalent expressions. And usually an equivalent expression is a simplified version of an expanded expression. So here we've got w plus l plus W plus L. So basically this is the perimeter of our rectangle. But we can bring that together by just grouping our like terms. So we've got W and a W, so that means we've got two lots of W, and an L and an L, so we've got two lots of L. So we're going to have the same answer whether we substitute it into this first equation or whether we substitute it into this second equation. So since we've got a bit of time, let's just see. So let's let W equal, it can be equal to anything. I'm going to let it equal 10, and let's let L equal 6. Okay, so they could be anything. I've just made them up. So let's look at substituting those values into the first equation. So we've got 10 plus 6 plus 10 plus 6. So 10 plus 6 is 16, 26, 32. Okay, and if we substitute it into the second equation, we're going to have 2 times 10 plus 2 times 6. 2 times 10 is 20. 2 times 6 is 12. And then we go, just proven that they are equivalent. Okay, this section is not too difficult, so I didn't feel like the need to do too many questions, but do make sure if you are struggling with anything that you let me know. Okay, bye.